project is Lindsay jumping off of different heights of diving boards, and we are calculating the velocity. Our calculations aren't perfect because of human error and because we didn't have scientific equipment, and also we neglected air resistance because the distances were short. So this is the first one we did. We're trying to find the final velocity as Lindsay free falls down this 1 meter board. Her initial velocity is 0 meters per second, and we calculated the time to be 0.5 seconds with a hand watch, but we can actually find the actual time since we have the distance using the equation d equals 1/2 g times t squared, which is also equal to 1 equals 5t squared, and we found time to be 0.44 seconds, which was pretty close to our the time that we found. And then using that, we can find the final velocity. We can plug it into the equation. Final velocity equals g times t. Final velocity is equal to 10, which is the acceleration due to gravity, times time. And then when you plug in time, you get 4.4 meters per second as the final velocity.
Okay, ready? 1, 2, 3. So now we're going to calculate the free fall off of the high dive, which is a 3 meter board. Okay, so again, like the last one, we're going to find the final velocity. Okay, so to find that, our initial velocity is obviously 0. With the hand timer, we found that it's 9 seconds. But the actual time, if we look at the same equation, d equals 1/2 gt squared, the time is actually 0.77, which is close, but not exact. So we're going to use the exact one in this equation to find the final. So this equation is v equals gt. And so just gravity, which is 10, times the time, which is 0.77, giving your final velocity to be 7.7 meters per second.
In this example, we were using the shortboard again, but this time we had the initial running start. So you have an initial velocity, but no jump or anything. So you're trying to find the initial velocity and the final velocity when Lindsay hit the water. The givens that we know is that, again, it's the 1 meter board, and she fell, the distance that she hit the water at was 2.7 meters from the board. And the time was 0.44 seconds because we were able to use the same equation for the free fall. So to find the initial velocity, we use the equation distance is equal to rate times time, or 2.7 is equal to 0.44 r. And we found that the rate is equal to 6.136 meters per second, and that's the horizontal velocity and the initial velocity. Then to find the downward velocity, we have the equation 10t, or 10 times 0.44. So the downward velocity is 4.4 meters per second. And then you can put it into this little triangle to try to find the diagonal velocity. And using the Pythagorean theorem here, you find that the final velocity of Lindsay's jump is 7.54 meters per second, and that's here.
Yay.
Okay, go.
Okay, so this one is me running off of the high dive. Okay, so here we're going to try to find the initial velocity, and the final velocity. Okay, so using our calculations from the other ones, the time on this is 0.77 seconds. At the pool, we measured the distance that I entered the water, and that was 3.66 meters. Okay, so using that, we can use distance equals rate times time to figure out our initial velocity and our horizontal velocity. Okay, so plugging in this, we can figure out that the initial velocity is 4.7 meters per second. Okay, so then now we're going to try to find the final velocity. Okay, so on this triangle you can see this is our horizontal, like there's imagine here there's like a triangle. This is our horizontal velocity, which is 4.7. Now to find our vertical velocity, we're going to go here. We're going to use the gravity times time, time being 0.77, to figure out that it's 7.7 meters per second once it is entering the water. Okay, so using this triangle right here, we're going to figure out this side, which will be our final velocity. Just using the Pythagorean theorem, we can figure out right here, we can figure out that this side is 9.05 meters per second, which is our final velocity when I entered the water.
Okay, so for this final jump, Lindsay jumped off a high dive again, but this time she did it with an initial angle. So the givens that we know is that the board is 3 meters tall. The jump took 1.5 seconds. The distance she fell from the board was 4.57 meters. And using pictures from the stop motion camera, we were able to approximate that her angle at which she jumped was 57 degrees. And from the picture of when she was at her peak of the jump, we approximated that it was about 1/3 of the distance from the water, so another meter. So we have to find initial velocity and final velocity in this problem. So first you have to find the initial velocity from her original jump. So you use the equation d equals rate times time to find that the horizontal velocity, is 3.05 meters per second. So that's the horizontal velocity throughout the whole problem. And then you use trigonometry and you have the cosine of 57 degrees is equal to 3.05 over x, or 5.6 meters per second. And that's the diagonal velocity, so that's the initial velocity of the problem. But we also want to find her upward velocity. So to do that, you find the tangent of 57 degrees, which is 4.7 meters per second. And when you put it all in this triangle, it all adds up with the Pythagorean theorem. So then the next part of the problem that you have to find is her final velocity. But to do so, you have to treat this part of the equation as something different. So you treat this as a free fall motion from here instead of factoring in the beginning part of the problem. So you use the equation d equals 5t squared, where distance is the distance fallen, not the distance traveled. So you add 1 meter to 3 meters and you get 4 meters. So 4 is equal to 5t squared, or the time out of 1.5 seconds that this part of the jump took to complete was 0.89 seconds. So you use the equation final velocity is equal to g times t, or 10 times t, and you plug in 0.89 for the t, and you find that the downward velocity is 8.9 meters per second. And then you already know that the horizontal velocity is 3.05 meters per second, so you just use the Pythagorean theorem to find that the final velocity of Lindsay is 9.4 meters per second when she goes off the high dive like this. I have something to say to the class. Lindsay is the most distracting person I know to
I
work
agree.
with. I would not advise
second
working
that.
on any sort of project with her, ever.
If she ever offers to work with you, just say no.
Just know that it's a trap.